Hey math kids, today we're going to talk about the properties of ax plus b, and so the expected value of k is just that constant. So if we take the expected value of a constant, it's just the constant. Now if we have a constant and a random variable, then we can just take out the k. If we're finding the expected value of g and h, and they're added together, we can take the expected value of each of them individually and then add them together if they're functions. This is similar to kind of combining these two. So a and b are constants, so we can just take the a out, find the expected value of the discrete random variable, and then the expected value of a constant is just that constant. So once again, it's just combining those. If we take the variance of ax plus b, we can take the a out front and square it. And then because the constant is not going to affect the variance, we just kind of ignore that. And then with standard deviation, we can do something similar. It's just we take out the a, and that's the absolute value of a. Okay, we do have an example. So the random variable x has a mean of 8.1 and a standard deviation of 2.37. Okay, let's see, it says if y is equal to 4x minus 7, find the mean and standard deviation. Okay. So, if we just find e of y, which is the same thing as e of 4x minus 7, this will be our mean. So we have 4e of x minus 7, applying this one. And then we just plug in, we know what the mean, mean is just e of x, and we plug that in, so 8.1 minus 7, we plug that into a calculator, and we see that the mean is 25.4. When we're doing the standard deviation of y, we use this one, and so that's the same thing as the absolute value of 4 sigma x. We know that the standard deviation of x is just 2.37, so we get absolute value of 4 is just 4, so we get 4 times 2.37. If we plug that into a calculator, we get 9.48. So that's our standard deviation. Yeah, if you have additional questions, come to Math Lab. Until then, calculator.